Hi guys, welcome to the channel. So in the previous video we were discussing about the Woodward Fieser rules to calculate the lambda max. So now we are on to the application part of it and we are going to solve some of the questions. So we will start with the practice questions. So question number 1 is, so before starting that I would highly recommend you guys to get those papers on which you have written all the rules. So that is going to be very helpful for you. So now starting out with the first question. First we have this molecule. Now this is the molecule and we have to find out the lambda max for this molecule. Now in this molecule, first we need to find out the base value. So first we need to look at the system. Now what sort of a system is this? This is a heteroannular diene, right? This is heteroannular diene. Both of these double bonds are present in different rings. So for heteroannular diene we have base value of 215 nanometer or millimicron, you can say. Now we will look for the ring residues. Now how many ring residues are there? 1, 2, 3 and 4. 4 ring residues are there. So for 4 ring residues we will go 5 into 4, right? For 1 ring residue we add 5 nanometer. So for 4 ring residues we will add 20 nanometers. So total lambda max will be 215 plus 20, that is 235 nanometer or millimicron, right? This was the first question. Now moving on to the second question. This is the molecule. Now which type of system is this? This is butadiene type of a system, right? From here you can see this is the butadiene type of a system. For butadiene system, what will be the base value? Base value will be 217 nanometer. Now we will look for ring residues or alkyl substitutes. Now ring residues are 1 and 2, right? So for 2 ring residues we will go 2 into 5, that is 10 nanometer. Now we will look for the alkyl substitute. Now in this molecule we have only one alkyl substitute, right? For this particular alkyl substitute we will have 5 nanometers, right? So overall lambda max will be 217 plus 10, that is 227. 227 plus 5, 232 nanometers, right? This is the lambda max value. Now moving on to the third question. The molecule is this sign basically means that from here we have so many groups, but we are not going to represent that whole molecule from here onwards. So instead of drawing overall molecule, we do this bracketing, right? Now this is the molecule. Now what sort of system is this? First of all, this is a heteroannular type of a system. So for heteroannular type of a system, we are having base value of 215 nanometers, right? Now look for the ring residues. Ring residues are here, here and here, right? These are the 3 ring residues. So for 3 ring residues, we are having 3 into 5, that is 15 nanometer or millimicron, right? Now one more thing is there is one exocyclic double bond here. So for one exocyclic double bond, we will add 5 millimicron or nanometer. So overall lambda max will be 235 nanometer. Yes, it is 235 nanometers. Now moving on to the 4th question, we have this molecule. Now this is the molecule. First we will look for the base value. So for base value, first we will go for, see here we have both homo as well as heteroannular. So we will give preference to the homoannular one, right? So we will take up this base value for homoannular dienes. So base value will be 253 nanometers. Right, now we will look for the ring residues. So here are 1, 2, 3 and 4, because this part is for the base value. So around this part we have 4 ring residues. So for 4 ring residues, we will go 4 into 5, that is 20 nanometers. Now there are actually 2 exocyclic double bonds present here, right? For this ring, this is the exocyclic double bond, right? And for this ring, this is the exocyclic double bond. So for 2 exocyclic double bonds, we will go 2 into 5, that is 10 nanometers ahead, right? Now here actually we are not able to see full molecule here, but if you could remember, this was for the base value, and this double bond is extending the conjugation, double bond, single bond, double bond, single bond, double bond. So this one is extending the overall conjugation of this system. So for one double bond extending conjugation, we will add 30 nanometers, right? And overall lambda max will be 253 plus 20, 273 plus 10, 283 plus 30, 313 nanometer. This will be the lambda max, right? Now before moving further, One point to note here is that you can note it down also. If the diene system is present in bicyclic compounds, bicyclic, BICYCLIC, bicyclic compounds, then due to strain in the rings, 15 nanometer is added as the ring strain correction, right? Ring strain correction in the calculated value of absorption maximum. You can pause in between and you can write it down as the note point. So I will repeat that. If diene system is present in any bicyclic compound, then due to ring strain in the rings, 15 nanometer is added as the ring strain correction in the calculated value of lambda max, or what we say as absorption maxima. So we will understand this point with the help of an example. So here we are talking about bicyclic system, right? So first we are having some sort of bicyclic system like this. This is bicyclic systems, and suppose this is the overall molecule. For this we want to find out the lambda max, right? First of all we need to find out the base value. For that, this is the butadiene system. For that we will be having the base value of 217 nanometer. Now we are having two ring residues. So it is 2 into 5, that is 10 nanometer. Now here are two exocyclic double bonds, right? So for two exocyclic double bonds, we will add 2 into 5, that is 10 nanometer, and we will add the bicyclic correction, right? This is a bicyclic system, and in bicyclic system there are two rings present, right? There are two rings which are present, and due to the strain in these rings we add correction in the lambda max, and that ring correction value is 15 nanometers, right? So if you are able to see any type of bicyclic sort of a system, then you will add 15 nanometer as ring correction. So total will be 217 plus 10, 227, 237 plus 15, 252 nanometers. This is the lambda max, right? So this was what about the bicyclic system, which we wrote down in the note, right? So this was all about the Woodward Fieser rules to calculate the lambda max. So these were some of the practice questions, and I hope with these questions you are able to find the application part of the Woodward Fieser rule. So far that's it for this video, and with this UV visible spectroscopy is over, right? And we will try to solve some of the questions related to this topic in a separate set of videos, which will be in a separate playlist. So far that's it for this video. Thank you so much for watching.